Okay, let's do problem 144a, count good nodes in binary tree. So let's quickly go through the example. So we have something called nodex. Nodex is used to get the path from root. So if it's at node 3, which is a root to node x, in that path, which is basically root to root, is that number greater than max? Well, it's the only number. So 3 is a good node. So the count goes up. When we look at 3 to 1, this means that 1 is node x. Is this number greater than or equal to max? No, it's not. And then when we look at this path here, that means that's node x. Is 3 greater than or equal to max? Yes, it's same. So count goes up. And we repeat the same process to get 2 additional good nodes, and then count will become 4. That's why the output is 4. All right, I'm just going to remove this one. So, as I just explained, this one, when we are checking if this node is a good node or not, we were using the max value. So, and as for the other DFS questions, we need to recursively call the function, and which means that this node will call some function to count good nodes for this one, and then good nodes for this one, and then this will use 2 other child nodes, and so on. That means that recursive function needs a reference to the max value, which means that needs an argument of max value, but this function does not have that. So we do know that it's not a recursive function. So we need to create a private function that's going to return, and I'm going to call it count good nodes. So it needs tree node, and int max, but we can rename it better because for every iteration we are going to update our value, max value, so we can say max so far. And initially we're going to, so this will get the number of good nodes, and then this function can return that number. So it will be count good nodes. And we are initially going to put root into it, and then the max will be nothing. So we can put the lowest value. All right, so let's assume root is here. And we need to work out int number of good node. Initially it's going to be 1. So the reason is node.val, which is the root, is greater than or equal to max so far. So in that case we're going to give 1 and then 0. So we're off to a good start. Root always becomes a good node. And then we can update our new max value. So we can simply do math.max and then max so far, and then node.file. Good. So this one has finished, and then it needs to recursively call these 2 child nodes. So will be return count good nodes, and then node.left, and then new max, and then count good nodes, node.right, and then new max. I guess the biggest challenge in this question is how we can count the number of good nodes. Let's think about the easiest case. Suppose we have 3 and 4 and 5. So if we put root here, number of good is 1, and then we are calling for left for this 4 as well. So node that left is 4. So that means node becomes 4, and then we again get number of good to be 1, and then new max of 4, and its node that left is null and the node that right is null. So that means we do need some function for if node is equal to null. So at the moment, from full iteration of this node 4, number of good is 1. So, and if we do number of good plus, and then do plus for this one as well, and that means we're returning 1, and this one there is no child nodes, so in that case we can return 0. And from the root's perspective, when that count is finished for the left side, this will give 1, and then root already has 1 here, so we are incrementing the counter, we're incrementing the number of good nodes correctly, and then same thing will happen for here. Let's run the test. Okay. All right. The whole solution is quite intuitive, but we're basically, instead of keeping track of number of goods, we're returning the number of goods for each method. Call. Let's have a look at this one. Yes, they're basically doing the same thing. All right, that's it.